Hey there, thanks very much for joining me. I'm Dean, and today we're going to be talking about what these come from. These are my prototypes for the zero clearance insert plate for the Evolution R255TBL, and finally you'll be able to make your own. So when I designed this, my idea was that I was going to print these and sell them, because at the time Evolution didn't offer their own options for doing such a thing. But I've had to change my mind on that one a little bit. You can still get one, but let me tell you more. You see, the challenge that I faced was, in my head, liability. So in my brain, if I produce something and then sell it to you guys, and someone inexperienced, because let's face it, the Evolution saw is available to literally anybody. If I made it and sold it to you and you hurt yourself, I don't know if I'm liable, but I know it would feel terrible on my part. Now the thing is, recently I believe Evolution has run out of stocks of their own zero clearance throat plate, which I looked at. Did I do a review on it, or did I do a first impressions? But I looked at a little while ago. Link to that video below. And because it's not been available at the moment, I've been inundated, and I know YouTubers say this a lot and most of the time are talking absolute nonsense, but I have been inundated with messages and comments for people asking if they can get hold of mine. And so mine, basically, this is a bent one because I've had it badly stored, just replaced the original throat plate, has a lock on it, and is zero clearance, which, great. So this is how mine goes together. It should be pretty simple and straightforward. They're all 3D printed parts which just work. So we've got those two parts, which these are the lock system, and we've got these two parts which are the plate. Now what we do have right here is the lugs that will help you kind of match everything up. Sometimes when they print, they have these little bits of sort of schmutz on them, so we can take that out, and if you do have a problem with the printing, you can always sort of just trim those little bits off, but they should fit into those holes nice and snugly, and it'll just mean that you can locate everything nice and proper together like that. But this still should be glued. Banging over the edges with a knife is never a bad idea when it comes to a 3D print, just to make sure that you haven't got any sort of little bits and bobs of offshoots and bits of filament where you don't want them and all that sort of nonsense. Right, so when it comes to gluing these up, I'm using 03. Unfortunately, I've run out of the accelerator, so I've got some other stuff that I'll use today, but I am an ambassador for these guys. I think it's really great CA glue, but you can use whatever glue you fancy. So what I'm going to do is I'm just going to pop some glue in the holes and just all around here like so. Just like that. Then on the other side, I'm going to spray a little bit of the accelerator, and then we're going to put them top down, match them up. Sorry if my head was in the way then. I'm just squeezing them together as hard as I can. Okay, so now that's glued up. These are the two parts for the lock. You've got those locating pins as well, so you can't really mess that bad boy up. There is probably a little bit that I could just trim off there, but it's not really that essential, to be honest with you. What I'm going to do now is I'm going to pop the top one with the screw hole in the top there, and the bottom one fits onto there just like so. Okay. Now it doesn't snap fit, we do need to pop a little bit of glue in there as well. So I'm just going to pop a couple of dabs of glue in here. We don't want any squeeze out to affect the to get this stuck to the actual unit. Obviously that would be bad. Right, where are the locating holes? They're here somewhere. There they are. Sticking those together like so, moving that around to make sure nothing is sticking. And you'll see that on here, maybe, that we've got a little bit of a slope which helps locate it. This hole right here is your finger hole, and then you've got the access to the rise and fall holes as well, so you can make sure it's nice and straight in your table saw. Speaking of which, let's get that in here. So this is where things start getting a little bit on the ropey side. What we want to do is lift the blade all the way up, and then we can make sure that we get make sure your blade's locked down as well, and then we can get the riving knife out of the way. Then we're going to lower the blade all the way down. And I'm just going to double check to make sure that this blade isn't on an angle. Lock it in place. Okay, now if this goes on the top here, we've got to make sure that the lock is not engaged, like so. And then we engage the lock, and now that's kind of in there now. What I would do for extra safety is bring the fence over, and we're going just over on top of the throat plate and locking it down. Okay, I've plugged the saw in. Now I'm going to turn on the blade and raise it slowly. I raised it up and down a few times just to make sure this area was nice and clear. Unlock the throat plate and pull it out. We do also have, by the way, a little tab at the front here that I forgot to mention earlier, which actually goes into the front of the housing there, which is great. Now, the problem we've got is obviously there's no space for the riving knife, and we must use a riving knife. So how do we do that? Well, it's dodgy, but this is how I do it. Reinstall your previous throat plate. This then gets flipped over onto its top, and then we raise up the blade. We try and get the blade to sit in the hole that we just made. The fence comes across, and we're not smushing this into the side of the blade. We're still allowing for a little teeny tiny bit of space there for the teeth. And when you're doing that, you'll be able to hear if the teeth are hitting the plastic or not. I'm going to use one piece of wood to push this up against the fence, and another piece of wood to slowly move it through the fence, or a push stick like so. But we do want this to have pressure downwards and against the fence. And that cut, my friends, is why this is not a beginner level bit of kit, in my opinion. So we've got to guess kind of how far up we're going to do the cut, but we'll do a test fit and find out. Obviously, increase the height of the blade to maximum. Reinstall the riving knife and bring it down again. Okay, with the riving knife back in there now, we want to raise the blade like so, and we can come all the way up, and right at that end is still fine and dandy. So if you have any problems like I did right there, where when you go all the way down and come back up again, you're sticking a little bit, that's something that you can use a bit of sandpaper for, or to sort that out. And then finally, you should have access to the 4 holes that you've got to make sure this is sitting flush with the top. And that is the zero clearance plate that I came up with. And you can see that was the top And the breakout, even on this OSB, is pretty low. One thing I should say is I am not charging for this, and I spent a heck of a lot of time trying to figure it out and sort it all out, but I'm not going to charge for it. And so if anybody is selling one of these with my design, and I've got some hidden sort of stuff on the inside of it, then they are doing so without my permission. So please don't use them. Just go to the STLs. If, however, you appreciate the hard work, you can always make a payment if you want to, or a donation to the channel, and the links to that will all be down below as well, and that would be much appreciated because it costs a lot of time, energy and filament to make this bad boy. And that, ladies and gentlemen, is my zero clearance plate. So how do you get hold of one? Well, I am not going to sell them because there are clearly some aspects to the installation of this that are a bit dodgy, and you need to know what you're doing. What I would say is, if you're unsure about using the table saw for the higher part of the slot, then using a jigsaw, a file, sandpaper, whatever, handsaw, is going to be a safer way to go. Now, when it comes to materials, I've tried PLA and PETG. PETG is a bit more splintery than PLA, but having said that, it works just fine. Now then, as I said, I'm not going to sell this, and I do not want anybody selling my design because of the same reason, from a safety point of view. However, I am going to upload it just onto MakerWorld. So if you've got a Bamboo Lab printer, or you know someone that has, then you'd be golden. There are printing solutions. People offer printing in most areas, so go and check on Marketplace or something like that. So if you've got someone who does printing locally and has a Bamboo Lab printer. The reason I'm sticking with Bamboo Lab is because that's what I have, and I know from an accuracy point of view it printed things pretty damn well. So I can't say the same thing would definitely happen if you used a Creality or any other type of printer. Okay, so like I said, I'm not going to sell them, so I'm not going to print them for you, and that's just from a liability point of view. I am offering the design to be used but not resold, and there'll be a link in the description down below if you're interested in getting your own. Okay, hopefully that's okay with you. Don't come at me if there's any problems with it. I've tried my best. It works fine for my saw, and I'm not making any more edits or changes to it because I'm no longer using this saw for most of my work. Okay, thanks very much for watching, and I'll see you very, very soon. Bye-bye.